morning, dear all. Good morning and welcome to the third day of Connecting Tomorrow. It always makes me a little bit feeling sad, I would say, to introduce the last day of such an amazing conference. But on the other hand, when I look back at the last 2 days that we had, I must say it was amazing. And I'm quite happy to announce that we are having a lineup today which is second to none when it comes to conferences for today. We have panel discussions, we have speeches, we have keynotes, and we have, of course, also in the afternoon, we have workshops. So it's definitely worth being with us today. And I'm very happy also that we are here in the situation of having a virtual and hybrid conference as well, because I know many of you are connected there outside, somewhere in the world. I don't have any clue where you are, but it's very good that you are with us. And I just enjoy being with you virtually. For sure, it's a little bit different having to look into a camera and not necessarily into so many people as we used to be some time ago. But that changes, and that's great. Matches also very well the topic of the conference, Connecting Tomorrow. Tomorrow starts today, and tomorrow is the future, and we are paving the road to the future. A couple of housekeeping rules. And housekeeping rules sounds always a little bit awful, but I have to give them. There's nothing bad about this in this case, just good things. Because the first thing is, our conference will be in English. But we know that not everybody necessarily feels comfortable in English, and therefore we have also interpretation. So you can choose your language, and that's pretty straightforward. If you're connected virtually, just click on the little globe button on the side, on the left side of the internet side, and you will be guided to the process on having your translation, your interpretation ready. It's pretty straightforward, and you can have German and you can have French. If you're here in the room itself, no problem at all. We don't have any more the classic old headsets that we distribute, but instead we are much more modern. We are going for your own smartphone, and you can, just as you do when you're connected virtually, you can connect through the smartphone to the interpretation app. Use your own headphones, and then you're good to go. You're going to have your live translation in your ear right away here in the room as well. That's also part of Connecting Tomorrow, because that would not have been possible, let's say, 4, 5, 6 years ago. A little bit more modern. We are shifting gears. The other thing is that if you have any questions, we don't have any microphones anymore here in the room. But we also don't have any microphones, of course, in the virtual world. And therefore, we have a section on the website, on the event website, which is called Questions, where you can submit your questions, and I'm going to have them right away. I'm going to have with me, and I can ask them to the speakers. And I really invite you also to participate as active as possible, ask as many questions as you can, because only this makes our conference interactive. And we are not here only to speak to you, but we are also here to speak with you. And that only works if you ask us things. And therefore, I invite you really to go and to ask your questions. Even if you're here in the room, we don't have any microphones anymore that we're circulating if there are any questions. You can also connect to the app, to the event app, and there you have the possibility, just as in the virtual world, to ask your questions, which are going to end up right away here on my device, and I'm going to ask the questions to the speakers. The third thing is that we have a networking area. We have a virtual networking area that you can use. I'm pretty sure you have filled out already your profiles. Then go and network, not during the speeches, of course, during the networking breaks. And if you're here on site at the Lux Expo here in Luxembourg, then of course use the time also at the networking lunches or breaks and mingle with the other people, forge new connections, use the time to discuss, to see what the future might bring also in terms of new connections. And last but not least, we have over here, but also in the virtual area, we have our exhibitors, our exhibitor area, where we have different companies from Luxembourg showcasing their projects in the 5G area. It's extremely exciting what they are doing, so if you're here, don't hesitate to go over there and have a look what they are doing, discuss with them, and be impressed. And the same also in the virtual world. We have exhibitor booths for them in the virtual world. You can go over there, and even on the exhibitor booth, you can also mingle with the other visitors on these booths. So it's a great networking opportunity as well. Just Feel free to use it and enjoy it most of all. Let me have a look back at the last day. Yesterday was a day which was full of interesting discussions, interesting speeches that we had. We started off in the morning with Bilal Jamoussi from the Study Groups Department of the Telecommunications Standardization Bureau, ITU, in Switzerland. And Bilal was mainly speaking about AI for good. How can you bring connections to those countries which are maybe not as developed now as North America, Europe, or maybe parts of Asia? What can you do to bring connections to everyone? How can you make sure that 5G will bring broad connectivity to a wider audience, also Internet of Things, which is the foundation for it for sure? What about energy efficiency and e-waste? And then also how to measure smartness of more sustainable cities. All of this was in Bilal's speech. It was very exciting also to listen to him because he showed so many information. I cannot replicate now everything that he said, but it was mind-opening, that's for sure. Then we had a panel discussion, creating a sustainable smart city. We had Matt Clifton from the Smart City program from the Leicester City, and we had Teppo Rantanen, the executive director from the city of Tampere, from Finland with us, both extremely active on building the smart city of the future. We had very interesting discussions about why, for example, Nordic countries are partly a little bit more advanced when it comes to that. Why, for example, people in northern countries are more open to transmit their data without big hesitations to the governments or to the bodies who are regulating all this. We had also very interesting discussions about how smart cities today can help to eliminate waste, to reduce power consumption by having smart power grids, by controlling better how smart vehicles are driving around. And also, how can smart cities help with the inclusion? Those people who cannot really go somewhere because they are maybe disabled, maybe older people, or simply in the situation of a pandemic where we have the situation where people cannot, because of lockdown, mingle with other people and are maybe locked in their room at home and simply cannot go out. How can smart cities also help those people not to lose the connection to the rest of the world? It was a very exciting topic, and it showed really what the future might bring, in what kind of world we might live in the next 10, 15 years, just from now on. They are creating the future, and the future will be very quickly there, but it will be mainly also invisible for us. It will just work, and behind the scenes, quite an impressive technology will do it, based, of course, on 5G. Then we have the next speech, which was from Markku Niemi, as well from Tampere, from Finland, Senior Business Advisor, Connectivity. And he was speaking about 5G testbeds and their impact. The importance, what first of all a testbed is and how important testbeds are for 5G to see what works, how it works, and how it does help also to inform business decisions to make 5G operational really. He was speaking about what are the biggest challenge, the biggest learnings when it comes to public interfaces, systems, and architecture design, software development, when you're moving, for example, also to 6G. 6G that we will speak also today in some presentations about. So the next step, the next iteration, of course. And then also what's next? Markku was speaking about how to create new opportunities for businesses and to encourage inward investment. And then we moved over to the next panel discussion that we had, the take on Industry 4.0. Industry 4.0, and I was very happy actually having great speakers with me. In this case, we had, now I lost indeed my page. That's also technology, so sometimes it's scrolling, so I'm going to go right away back here. We had Kyriakos Exadaktilos, head of network architecture specifications from the Vodafone group from Spain we had with us. We had Dr. Alain Schumacher from the IEE group. He was the Chief Technology Officer from Luxembourg. And then last but not least, we had David Preuss, the Chief Information Officer from the Köln-Bonn Airport in Germany. It was exciting to see how they are planning to deploy on the whole airport area a private 5G network and how much easier it will be for them to connect all the different actors on this huge area, which is an airport, which is a highly and hyper-connected area, of course. How 5G will help to make it so much easier compared to using other technologies, such as Wi-Fi, for example. Alain Schumacher from IEE, he was more focusing on how 5G can help the industry itself to streamline and to improve their processes, to make the process management inside of IEE when you're producing things, how to make it easier. But at the end of the day also, as they have a lot of connected sensors which are built into cars that we're driving with, how can 5G help to dock into these technologies? So it was quite interesting because he was speaking really from both sides. On one hand, how to improve the process, and on the other hand, also how to improve the products that he's selling out to his clients. And then, well, with Kyriakos Exadaktylos from Vodafone, he was, of course, covering more the aspect how Vodafone, how the operators can help the industry also to implement all these necessary technologies in a rather fast way, because the deployment can be rather fast, or at least step by step. So that was extremely interesting also to see what kind of developments we have in this field. Then we moved over to Dorota Zimnock, industry expert from Belgium. She talked us about 5G and blockchain. And it was quite interesting also to understand that blockchain, which for a lot of us is most of the time related to cryptocurrencies, but how blockchain can be used in so many different fields just in combination with 5G to make our life maybe a little bit easier. She was talking about the logistics sector. How can, for example, blockchain and 5G help to do platooning when it comes to connecting trucks on the highway? How can blockchain and 5G, for example, help us if we need to identify ourselves or need to give our personal information, that we can choose and decide what information will be transmitted, a certain transparency that we're going to have. So many interesting case studies that Dorota had. So it was also absolutely mind-opening for me to see what kind of possibilities we have. And then we moved over to data centers and the energy consumption. Everybody should know that data centers have an absolutely enormous energy consumption. And who could be better positioned rather than Kevin Kent, the founder and the CEO of Critical Facilities Efficiency Solutions, who came straight over from Columbus, Ohio to speak with us. And he was making a presentation, what can be done with 5G to bring down the energy consumptions. He had a couple of great examples also. It was very interesting also to follow his speech to see what are the current ICT energy consumption trends and challenges, and how, for example, to effectively reduce energy consumption with the ICTs. And then we came almost already to the end of this day 2 with a presentation enabling the 5G technology transition. It was Marit Palor-Vita, the Director for Regulatory Affairs from the ETNO in Belgium, who came over, and she was speaking which is the most cost-efficient and environmentally friendly 5G network deployment, fiber rollouts or hybrid networks. She was highlighting how to avoid costly maintenance of aging network equipment. Can the equipment, for example, be reused? That was very interesting as well. And then, last but not least, we had a presentation which was, let's say like this, a little bit more critical because it touches each and every one of us. It was all we need to know about 5G deployment and electromagnetic exposure. What is it and how does it affect our lives? How does it affect us? And we had Dr. Sebastian Fay, Senior Research and Technology Associate Luxembourg from the Institute of Science and Technology, and Simeon Chatzinotas, full professor and chief scientist from the head of SICOM research group at the SNT University of Luxembourg. It was a very lively discussion that we had. Especially Sebastian was showcasing how they can simulate the effect and the radiation, for example, of 5G on the example of Esch-Belval, but also how you can scale it up to a whole country like Luxembourg. And then on the other hand, also the possibilities, how can you simulate certain specific cases, what kind of radiation you might have, and why 5G is not necessarily comparable also to systems like 4G, because we have a different structure, we have a different kind of magnetic fields which are built up. That was yesterday. Today is a new day, and today we're going to have again a list of very interesting speeches. And I'm not going to wait very long now anymore. I'm going to give the floor now to our first speaker, who's Eric Fournier, Director for Spectrum Planning and International Affairs in the Agence Nationale des Fréquences from France. And his topic will be the demand for spectrum. And I think I can clearly say, when I was a little bit younger and I had my first cell phone, sometimes I was looking for reception, like I was looking for gold. Today, I feel that it's more the spectrum which is new gold, isn't it?
Everyone, and the response is yes. Spectrum is like gold. In fact, in these 20 minutes, I have to explain what is my job, spectrum management, and also to explain why spectrum is often seen as the bottleneck for the future connectivity and how we work to ensure that this is not so much the case. And maybe my ambition this morning is really if you have some innovations for applications or technology using the spectrum, that you will understand in advance how to do to ensure that you will not face, when that will come on the market, some difficulties with accessing spectrum. So just one moment to make you realizing what means access to spectrum. For most people, that's something which is obvious or even meaningless. It's just physics. Spectrum is there, you just have to use it. But this response makes me thinking a little bit about my children when they were young, when they were wishing to buy something and I explained it's too costly. The response from them was, just go to the cash machine, money is there. That's simple, but you know it's not as simple for that, at least if you are a parent. So spectrum is scarce, that's a reality. And why? Because if you use one frequency band, you may interfere with another user of the spectrum, the same band, or even with a user in an adjacent frequency band. Because waves propagate everywhere through walls, through borders, and also the signals cannot be perfectly filtered. You have some signal in adjacent frequency bands, so one user in a frequency band may interfere with a user in another frequency band. Also, spectrum is not only about connectivity in the sense of Wi-Fi or 5G. There are many spectrum needs. You have satellite radio navigation, of course, GPS, Galileo. You have satellite broadcasting, you have terrestrial broadcasting, you have radars also for defense, for civil aviation, for meteorology, for maritime. You have many civil aviation equipment for landing, for communication, for safety, for security, also a lot of maritime equipment. You have Earth exploration satellite, you are observing the Earth through the measurement of radio noise, and that's something which is very sensitive to interference. You have also need for space research. When you go to Mars, you need some communication with Mars, and that's also a spectrum. You need spectrum for utilities, for emergency, for defense system that tactical communications, weapons. You also have all short-range device like RFID, like smart home, and I forget a lot of them. Just to say that all these users of the spectrum also have need to spectrum. It's not just about connectivity in the sense of 5G or Wi-Fi, it's much broader than that. So what frequency management is all about? It's to define conditions to ensure that all these users in the same frequency band and in adjacent band can operate in the spectrum without interfering each other, to keep some kind of orthogonalities. So if used in the same spectrum, you can ensure some kind of geographical separation, for example. Geographical in the wide sense. For example, satellite communications and radio relays, fixed links, have often used the same spectrum, sharing the same spectrum. Why? Because if you have satellite communications, you have an energy which is focused through the antenna in the, toward the skies. And if you are radio relay, fixed link, you have something which is in the horizontal plane. So that's something which is nicely sharing with each other. Separation, orthogonality, can also take place in the time dimension if you have limitation, duty cycle, for example, and the use of a polite protocol like a listen before talk or opportunistic access protocol. Those are solutions. You certainly know about UWB, ultra-wideband, where the solution is to spread the spectrum in a so wide band that the spectrum density, the power density, is becoming so small that it's negligible for the other user of the spectrum in the same frequency band. As you know, mobile connectivity was very demanded. If you take the GSM 30 years ago, the beginning, that was 50 megahertz. 50 megahertz. And Wi-Fi, it was 80 megahertz in the 245. Now, mobile, 5G, 4G, and all that, it's 1 gigahertz of spectrum below 4 gigahertz. So multiply by 20. And 25% of the spectrum below 4 gigahertz, and this is really the golden spectrum mentioned by Peter. Wi-Fi, it's same 1 gigahertz of spectrum below 7 gigahertz, so something like 15% of the spectrum below 7 gigahertz. It's enormous. It was really a revolution in terms of spectrum management. Now, this kind of application can also access to millimeter wave, to higher spectrum, where, of course, you have more bandwidth. There's something like 6 gigahertz for 5G in the millimeter wave, and something like 14 gigahertz for Wi-Fi, WiGig, in fact, or local connectivity. But you need in the 60 gigahertz range, but you need to understand that in millimeter wave, propagation is not so good. Walls are walls in the millimeter wave, and you always need, if you want to have some kind of coverage, you always need to access to this golden spectrum in the frequency band below 1 gigahertz, or say below 7 or 8 gigahertz. And now with 6G, we can speak about data rate above 1 terabit per second, 1 terabit per second. If you have application like holographic communication, tactile internet application, Internet of Things, extremely high rate information showers. But you have also not only bandwidth, you have also some other KPI. You have the latency, which is becoming critical for autonomous driving. I also mentioned Internet of Things. You also need to ensure some high connection density with Internet of Things, massive Internet of Things for 5G, and that will be the same for 6G. At this point, I would like to make a distinction between 5G and Wi-Fi. 5G is something which is licensed, and that's making an important difference in spectrum management, licensed and unlicensed. For cellular, the right to use spectrum is granted by the regulator to the operator. And of course, operators wish to be able to deploy everywhere without any constraint. That, at least historically, what they have done. Now, in certain frequency band, they are able to share a little bit the spectrum. For example, in the millimeter wave, they sometimes have some constraint to protect few stations in rural areas, but that's something which is very limited. And even in the regulations for 5G, you have this kind of guarantee for operator for this spectrum that the number of other stations with which 5G will have to share will be limited and will not impact the coverage of 5G. It's really in the regulation. Also, latency requirement for 5G is also limiting the possibility to share, because if you have latency requirement, it's more difficult to have an algorithm to ensure the sharing, kind of polite protocol, because if you have such kind of algorithm, you introduce delay. And if you introduce delay, of course, the latency is affected. Wi-Fi is the other side, that's unlicensed. So unlicensed means that equipment can be switched on in frequency band without individual authorization. Of course, you have to comply with technical conditions, such as low power, polite protocol. You have to share with other Wi-Fi equipment. You have to share sometimes with other unlicensed devices, and sometimes you also have to share with incumbent services, primary services, which are also using this frequency band. This is an example of Wi-Fi in the 5 gigahertz frequency band, where Wi-Fi has to share with radars. And because of that, they have to implement what we call a dynamic frequency selection feature, which is enabling the Wi-Fi to listen to radars. And if they detect a radar, they have to stop transmission. But you need to understand that whatever it's 5G or Wi-Fi, the capability of sharing is always quite limited. If I take this example of 5 gigahertz, you cannot imagine a lot of radars in a center of a city which would prevent all Wi-Fi to operate. So even for Wi-Fi, which is inherently designed for sharing, you have a limited capacity of sharing because you need this Wi-Fi capacity. If not, Wi-Fi will have never been developed in the 5 gigahertz frequency band. Note that unlicensed band, that's an interesting issue in frequency management. It's a kind of sandbox where you have a lot of innovation. If you are some people trying to innovate in spectrum applications, you will often look first to the unlicensed spectrum. I was mentioning RFID and smart home, but there are many smart something which are relying on innovative application in unlicensed frequency band, in unlicensed spectrum. It was interesting to see in the past years the development in these unlicensed bands of low power wide area network using technologies such as LoRa and Sigfox, which were called 0G, zero generation, because they were simple, low bit rate, but high energy efficiency, simplified signaling, and also wide coverage, and that was really in unlicensed band. So the quality of service was ensured in a different way for this kind of application. During these 3 days, and Peter reminded that to you earlier, you have heard about Industry 4.0, smart cities, smart energy, smart health, what we call vertical. For all the application behind this terminology, behind vertical, that can be addressed in a licensed band and also through the mobile network operator, through the licensed frequency band. But there's something which is quite new in frequency management, in spectrum management. This is a need for certain vertical, and Industry 4.0 is a key example. Some need to have some local coverage with a license because they need high quality of service. It's obvious for Industry 4.0, just as an example. But in a way which is not through the operator, because you really need to design your coverage, to fit your coverage with your specific need in a specific area. So for that kind of application, some EU member states, Germany, for example, have identified some spectrum, 3738, for those knowing this kind of things. In France, it was 50 megahertz in the 2.6 gigahertz, so it was a separate spectrum. So we have one difficulty, just to illustrate what we are doing to accommodate this need. There was no real harmonization for that in Europe, and if you are developing some equipment, some application, you want harmonization. Harmonization is something which is key. So one of the work on which we will have to find some solution in the next few years is whether there's a possibility in the frequency band which is just above the 3.5 gigahertz, and that frequency band 3.8 to 4.2, whether there's a possibility to introduce this kind of applications for local broadband coverage, limited to low and medium power, probably because they will need to share with Earth stations, satellite Earth stations, which are operating in this frequency band, which were moved from the 3438, which is a primary 5G band, so to ensure that they will be able to continue to use and to be deployed in this frequency band. So back to our initial question, should we fear not being able to cater to the growing demand in connectivity and network capacity? Are we expecting to become short of spectrum? Are we expecting that there will be a time when we will not be able anymore to respond to spectrum need of 6G and other innovative technologies? That was more or less the title of this intervention. And the response, in my opinion, is no. Why? First, it's not all about spectrum. Increase of connectivity and network capacity can be addressed with solutions also other than more spectrum. It's obvious for cellular. You have much more increase of capacity when you densify your 5G networks by creating new stations, and in particular by creating small cell. That's first the best solutions to increase the network capacity, and that's what 5G operators are doing. 5G has already many features to ease the management for the operator, to ease the management of small cell. There are also some regulations which have been put in place to ease small cell deployment all over Europe. So that was the case for 5G. That will be the case for 6G. Also, spectrum efficiency increase with time because technology evolves in the right direction. 5G was more efficient than 4G, and obviously 6G will be more efficient than 4G. Also, technology, I was mentioning that before, technology can also now access to higher spectrum, millimeter wave for 5G. And for 6G, we are speaking about sub-terahertz spectrum, which means, say, spectrum above 100 gigahertz, which will be the new Eldorado for 6G. You will have also a presentation about Wi-Fi. That's still very higher in the spectrum. So that kind of solutions is also helping to avoid the spectrum shortage. On the other hand, it's clear that this frequency and also Wi-Fi in frequency bands like a millimeter wave or sub-terahertz spectrum is not suitable for coverage. So you always need for an operator or for Wi-Fi or for whatever to have access to a lower frequency range. So if only part of the network resource demand is translated into spectrum demand, it's reasonable to expect some solutions to spectrum shortage. However, there's a need for time. You need some time to define regulations, to define technical solutions, to implement regulations. Sometimes you need to migrate some user of one frequency band to another frequency band. It takes time. It's not just like this. You need to give to regulator, spectrum manager, some time to do that. Also, there will be a need for more sharing. Even there's some limitation to that. Sharing of the spectrum is important, and we are also needing some innovation for sharing solutions, sharing innovations such as database, blockchain, or artificial intelligence, which may help in the spectrum sharing. For the timing, I have just 4 minutes for the timing. I can illustrate with the example of 6G. 6G, that's 2030 for 3GPP, ITU, deadline is 2030 for initial deployment. But it means that we will have to identify as early as WRC 27 the spectrum for 6G. But to do that, we already have to make the study as early as probably after WRC. WRC is World Radio Conference, so after the WRC 23, we will need to start this study and to see which frequency band, in which frequency band there are some possibility of sharing or possibility of migrating incumbent user. And even, in fact, in the next few months, we will start discussing the frequency band which could be suitable for 6G because we will have to maybe scope the study which will start after WRC 23. So we are in 2021 and we are preparing 2030. It's a long time. And Galileo, first time I was working on that, it was in 1999. So very long time ago to find some spectrum. Just a few caveats also, speaking about 6G. Sub-terahertz spectrum, you may also think it's a virgin territory because there's no user, but that's not true. There's a lot of users which are passive observation because you have in this frequency band a lot of spectrum lines like the oxygen, carbon monoxide, ozone. And these observations, I mentioned that earlier, is very sensitive to interference. So that will be one difficulty with sub-terahertz spectrum. You will not have a large bunch of spectrum. You will have to interleave with the spectrum lines, with the frequency bands which are necessary for this observation. And we are also discussing at WRC 23 some frequency band in the mid bands or in the lower bands which are very critical once again for coverage because 6G will not be only sub-terahertz spectrum. That will be also the need to access to mid bands. Mid bands is between 3 and 7 gigahertz. That's what is the best compromise between capacity and coverage. And below 1 gigahertz because that's what you need for being able to have coverage in rural area. So to conclude, I hope I was able to give you some insight about spectrum management and how we ensure that there's no scarcity of spectrum, at least for the innovation. I hope that you are now confident that you will have some possibility to have innovation in spectrum, to introduce new technology and new applications. And I also hope you will take care that spectrum management and need to access spectrum is to be considered at the earliest phase of your innovations, your ideas, and not something which is at the last moment. So many thanks for your attention.
Thank you very much, Eric. Just one last question, maybe more precision. Did I understand it right that actually the spectrum in 5G is not something which is already now fixed allocated, but which is kind of flexible, so where with the time, with new technology, also new spectrums can be added? Or is it something which is already infinite now?
5G, you have some frequency bands which was the initial pioneer band for 5G, but we are still working on some additional frequency band for 5G. There are today, if I take the millimeter wave, 3 gigahertz of spectrums which are identified for 5G in the millimeter wave, and there will be 3 additional gigahertz which will be harmonized at the European level in the 40 gigahertz frequency range, probably next year.
Perfect. Thank you very much, Eric. Very warm applause, virtually and in presence for Eric. Thank you very much. Now I need a bit of help here on stage because the next topic that we're going to speak about is verticals sparking new network models. Sounds a bit cryptical, but I'm going to dive in right away with an example that we had yesterday with the Cologne-Bonn Airport. The Cologne-Bonn Airport is spanning its own 5G network to connect the different areas. So this is kind of such a vertical with a new networking model. And how this works, I cannot tell it to you, but I have people with me who can. And as such, I can virtually welcome, first of all, Ms. Heidi Himmanen, who's the chief advisor from the Finnish Transport and Communication Agency Traficom from Finland. Heidi, welcome with us, and thanks that you're here. Then I have, next to us, I have Alexander Kühn, senior government official from the Federal Network Agency for Electricity, Gas, Telecommunication, Post and Railways from Germany. Actually, for the moment, you're the acting head of section on spectrum planning and international spectrum affairs at the German Federal Network Agency. You have a legal background and work in spectrum management for over 15 years, so I suppose that you know very well what you're talking about when it comes to spectrums. Tiago Rodrigues, CEO of the Wireless Broadband Alliance from Portugal. Welcome to all three of you. And I would say, without any further ado, Heidi, over to you. Maybe you can introduce yourself a little bit better than I could ever do.
Yes, thank you very much. My name is Heidi Himmanen, and I work as a chief advisor at the Finnish Transport and Communications Agency Traficom. And today I previously worked with spectrum management and spectrum supervision, and today I work a lot with innovation, supporting innovations and supporting research projects and uptake of 5G, for example.
Okay, perfect. Over to you.
Good morning, everybody. Thank you very much for your attention. Yes, my name is Alexander Kühn. I'm working for the Federal Network Agency. And as Eric already said, I'm working in spectrum for quite a while. We are doing the spectrum planning on the international scene, but also on the national implementation. And you can imagine that it is not always easy to have an international decision, which needs then to be convinced also on the national level for any circumstances, and the other way around as well. There are always wishes and demands which needs to be placed also and have an international dimension on the international scene, and therefore we are working intensively to really satisfy every demand in regards to spectrum.
Tiago.
Yeah, good morning, everyone. It's a pleasure to be here, and thank you for the invitation. So my name is Tiago Rodrigues. I'm the CEO of the Wireless Broadband Alliance. My background is on the telecoms. I spent 15 years in Portugal Telecom Group, where I manage innovation, Wi-Fi, roaming services. And lately, I've been working on the alliance that mainly focuses on Wi-Fi and how Wi-Fi can converge with 5G and cellular technologies. I'm looking forward for this panel.
Perfect. Thank you very much. Maybe let's start with kind of a basic question, because we're going to speak in the panel for sure about RAN, about Open RAN, and I'm not so sure that everybody in the audience knows exactly what a RAN, or especially also an Open RAN is. Who of you three would like just to give a quick overview what a RAN is? We have three specialists here. Heidi, you want to dive into this?
I think Tiago would be the good starter
I can
here.
start, and then Heidi and Alex can complement. So the concept of Open RAN is the radio access networks that are available, including Wi-Fi, 5G, 4G, LTE, and even 3G. So Open RAN is a trend, is a recent trend that is looking into the mobile core of the networks, that basically they are defined to incorporate not only the 3GPP cellular technologies, but as well to incorporate other RAN technologies like Wi-Fi or satellite services in such a way that an operator can have a transversal approach to deliver their services, and not only to deliver the services in one technology, so they can deliver the same service across multiple technologies. This has been an area of work on the Alliance, and many of our members, that includes operators like Orange, Deutsche Telekom, British Telecom, and others across the world, we have been focused on how they can have a network architecture that can deliver over Wi-Fi, for example, the same type of services that they deliver on a cellular network, in such a way that they can complement their deployments. In some cases, it's very useful and very opportunistic to use a Wi-Fi technology to provide extra capacity or extra coverage in a specific location. So that's what we have been working on in the Alliance.
Okay, Thiago, you mentioned now different networks, not only 5G, but also Wi-Fi, etc. Heidi, question to you. What networks are possible from a regulatory point of view?
Yes, maybe if I have one slide that I have provided, so I don't know if the production could put up that slide.
They are here. The slide is showing, so everything is there.
Okay, thank you. So this is just like an overview of what kind of different types of networks we can have today and in the future. So I just want to show you the diversity of different kinds of networks. Already today we have in Finland we have national mobile networks, 4G covering 99% of the population and 5G covering 70% of the population. So using slicing in these networks, we could also then provide for the vertical needs. We have local private networks, also spectrum available for that already in Finland and in Germany and other countries. We have enabled small-scale public networks in our legislation, also for other than operators. So, for example, in shopping centers, sports arenas, passenger harbors, and so on. And of course, fixed wireless access. And then we have large amount of different kind of temporary networks for events, maybe tactical bubbles, so moving a base station where you need it in case of an emergency or something like that. And we need to have then more dynamic spectrum use in the future to enable all this. We have sharing, infrastructure and spectrum sharing enabled today, will even be more common in the future. Neutral host networks means deep infrastructure and spectrum sharing, maybe public-private partnerships. We already today have dedicated networks for machine-to-machine communications, and even more in the future. The circles in blue are to show what types of networks we will have even more in the future. For example, the wide area private networks, I see this 3.8 to 4.2 gigahertz band, as Eric Bonnier mentioned, as a good opportunity to also provide private networks covering whole cities for smart city applications. Of course, integration of satellite and terrestrial in 5G and 6G networks, and so on. So this is just to give an overview. I think we as regulators need to take all these into account and to have enabling regulation to allow we do allow already for very much flexibility in the different network models today, and we even more need to do that in the future. Thank you.
Thank you very much. Alexander, a question for you, which is also kind of following up on what Heidi said. Spectrum, and we heard it also from Eric, spectrum is a scarce resource. Can you comment on the spectrum, especially now when it comes to 6 gigahertz, respectively also 12 gigahertz?
Okay, yeah. If you see all the networks Heidi just mentioned here, you can imagine that in former times we just had for every circle a single frequency band or a single frequency which was available and needs to be made available. You can imagine that this may not be completely efficient because sometimes they are geographically limited, they are just on a local side, and you may then block a complete resource on a national basis. So the question we had, and that's the challenge now, 5G allows us now to be more flexible and bring together all these networks. The thought of networks is now moving forward, and that is also bringing forward new possibilities of sharing between different networks, but allow on the other side to also meet the requirements. One aspect on that one, and that's a very critical one for vertical needs, for industrial applications, is the security side. If you think about it now, 6 gigahertz or even 12 gigahertz you mentioned before, 6 gigahertz has been used intensively by satellites, by fixed links before. It was not possible in the past to really share with those links in particular on specific points. Now we have the possibility, maybe on local base, but also if you build it up a little bit further, to allow there a better sharing possibility. And then with this thought, we came to the conclusion already at this stage that Wi-Fi 6E can be opened up in Europe in a first step between 5.9 to 6.4 gigahertz. And now we're discussing what we can do maybe from 6.4 to 7.1. Eric mentioned that band as well, and there are still interests moving forward also from the side from 5G technology, but maybe also for Wi-Fi technology. On a worldwide scale, both technologies provide interesting aspects right now, and we need to find out what is the best way here in order to allow sharing. To say that from a regulator policy perspective, in Europe you have to imagine that all the bands are authorized on a technology neutral basis. So you can switch between your different technologies and use different frequencies as well. But of course, in terms of harmonization, you need to take into account also the investment you have to take to build up the network. And that is usually the barrier there. So the MNOs, so the mobile network operators, are sticking to the 5G technology because that's their area, they have the exclusivity, and they know then the business cases which they would like to provide to the public. For other areas, and that's now for the verticals, they may be a little bit from a different thought, from a different angle to allow their network to prosper. And that brings then a little bit more innovation into the market and also maybe another deployment. The question to the regulator, if you look into the future, is then how we can build up this thought about network of networks, how we can really interlink those networks. And that's the possibility maybe which is coming up with 6G later on, where we then have more capacity because you're not always using the full capacity of your network, and then you can provide that to others as well. And that's the main thought of that, to really use spectrum more efficiently in the future, but not giving away any of your requirements.
Thank you very much, Alexander. Let's stay just for a little second with Wi-Fi 6, respectively also Wi-Fi 7, which is already kind of on the horizon. Again, spectrum. Thiago, can you elaborate a little bit more on the availability of spectrum for Wi-Fi 6, but also Wi-Fi 7?
Yeah, that's a very good point. So overall, the Wi-Fi, as any other technology, it has its own development. So there is strong advances in terms of Wi-Fi. So we have now Wi-Fi 6 widely available on devices and routers and antennas. Right now, many countries around the world are opening the 6 gigahertz band for unlicensed use. That is happening in Americas, in Europe, in Asia. And the standardization bodies are already working on the Wi-Fi 7 that will plan to be available by 2024. So Wi-Fi, like 3GPP and 5G and other technologies, has its own development roadmap. Spectrum. Of course, spectrum is a key element as well for Wi-Fi, especially when we are talking about unlicensed technology. Right now, as I said, many countries are opening the 6 gigahertz band. I'm seeing some different approaches to this opening of the band, of the 6 gigahertz band. I see in Americas, so Canada, US, Mexico, Brazil, and other countries being much more, let's call it aggressive, opening the entire 6 gigahertz band for unlicensed use, while, for example, in Europe, we are just opening the low end of the 6 gigahertz band. And I know that there's plans to revise this situation over time in Europe, but if nothing is done in the next years, we take the risk that in 2 years from now, 3 years, 5 years, we may even have almost a kind of a new digital divide that people from some continents will have faster speeds in Wi-Fi, will have better services, maybe teleconferences like AD is doing. If I'm using a country where I have more spectrum for unlicensed use, I can have more advanced type of services, virtual reality, augmented reality, while in Europe, we may take the risk to stay a little bit behind. So in my perspective, it's very important that the world and all the bodies that are involved on the definition of the spectrum, we align and we have a common approach to deploy the 6 gigahertz band for unlicensed use. And as Eric mentioned before, and Alex as well, this is a challenge for the policymakers and regulators, but there is a ton of techniques that can be implemented to do the shared spectrum and to have techniques that can allow the coexistence of different technologies using the same spectrum. And I think that's a big evolution for the regulators in the future, to be able to have those techniques and to implement those techniques.
Well, let's say it like this, technology is ready, but the bottleneck sometimes, I'm now the devil's advocate, the bottleneck are the regulators, for good reasons somehow. Heidi, I know that was not very nice actually to say it, but let's still have a look at Finland, because I have the feeling that in Finland everything is a little bit faster than on other places. How, in your opinion, Finland can serve, for example, as an example for quick regulations in the light of new technology?
Yes, well, I think one of the key is our spectrum policy. So the Finnish spectrum policy have made new spectrum available for mobile broadband networks very quickly and without fiscal costs. So our philosophy is to make it available. The large amount of available spectrum in different bands make it easier for the operators to plan and optimize the networks to enable more capacity and good service quality for the end users. And this has also led to, we have very cheap prices and we have unlimited data. In Finland, we use most data in the world per person. But then we have then opened up dedicated spectrum for local 4G and 5G networks and see a growing interest in building these private networks for industry campuses and harbors. And then we also very strongly support research and innovation by granting spectrum licenses. So we have actually also, the operators are very cooperative, and Finland is a very cooperative society. So in that sense, we have also granted licenses to the operator bands with their consent. Then we really cooperate to find the best regulatory solutions to support innovation and development, of course, without forgetting security and reliability. And then, well, from the perspective of spectrum use, our geographical position at the edge of the EU is a challenge. And the key for making the required spectrum available in Finland is the continuous dialogue and technical coordination with our neighboring countries. So I think, well, I talk about spectrum, but I really think it's the enabler, and then, of course, the other, enabling telecom regulation in general and flexibility, and to listen to the users and to listen to what is being developed. So I think we meet very well the requirements for today, and to enable the networks different kinds of network models that I just showed. But we need to work hard also to meet the future needs, and it's a challenge from the spectrum point of view also to allow more dynamic use and other kinds of new kinds of models in the future.
Thank you, Heidi. Alexander, you are covering more for sure the German part. Maybe you can follow up on this, share a little bit your experience from the German market. And I'm going to combine it right away with the second question to you also. Is Germany maybe going more for stability or for more flexibility?
just pick up what Heidi said. Well, I think the German regulatory authority is also there to really provide as soon as possible spectrum to the market. So we made spectrum available long before other European countries as well. We brought in this idea of 3.7, 3.8, so special spectrum for verticals at a certain point in time, and we were within the first ones in Europe who took this approach, which was directly supported then by the industry later on. So therefore we are not stable in terms of we are there and just providing stability of the regulation. We are thinking new ways away as well. And if you look into the discussion points we have for the last years, if you're moving up in spectrum, you have to think about other types of implementing them. For example, millimeter wave, we said that the auction is not the right way forward of bringing in and make this spectrum available. We said there is an easier path which may be more cost effective to every investor but allows also different sharing. And that was a change in the dynamics of maybe 5G implementation, and we will continue to do so. That's also what we do with regards to 6G, and we are already examining any possibility on different approaches as well. If you look into our latest consultation regarding the UHF band, so that's broadcasting frequencies. We also brought in the idea of maybe we have to turn to just a single operator of a single band in the UHF in order to provide a maximum capacity to the market. Of course, this has not been completely endorsed by everybody in the market, so we are just now analyzing what were the results of this consultation, but we are trying to be flexible and thinking about new things as well, in particular also then maybe database solutions which may provide also automatic authorizations in certain areas. That could be a possibility in the future as well, but of course, and there I with Eric, it takes time to implement this and think it through. I think Europe has one big strength. We are well ahead of the technology so far. We think ahead of the regulation, so we would like to keep pace with it, and we are very strong in implementation. So if there is a decision on a worldwide scale, we have a harmonized decision, then Europe is implementing it in a very thorough and regulatory stable, now I put the stability way forward, so it's also in a certain degree predictable, and that is endorsed by the industry in Europe, and that is still something we need to keep also for the future in order to really flourish the market of mobile development.
Just a question maybe for you, Thiago. I was learning from the former panel discussions that we had, especially yesterday, that with 3G, respectively also 4G, it was not necessarily a really European approach combined with the different countries. How is 5G? Do you see more kind of a collaboration between the different countries, more kind of really a common approach on it? Do you see a shift in this?
That's a good point. Personally, I don't see yet that shift coming from operators sharing somehow the infrastructure. There are some opportunistic situations, but not at a large scale. But what I would like to see more from the MNOs, the mobile operators, is that they have a more convergence approach to all these different technologies. And I know that all this conference is about 5G, and we have been talking about 5G and even 6G, but I think, especially the mobile operators, they have a huge challenge to deploy all these new networks, 5G, 6G coming. That's huge investments that they have to make. There is immense capital resources that is needed, and in many times by combining that 5G with other technologies, that can be Wi-Fi, but can be others. I will defend Wi-Fi, but can be any other technology. They will save them capital, they can optimize their investments. Probably the overall business case for 5G will be much stronger. And yes, if they can have that collaboration between them in terms of development of cell sites, development of infrastructure, that can even optimize more the investments. Because to have the type of speeds that we have been theoretically listening about 5G, we need very dense networks. And Eric before us talked about that. We need very dense networks to have that capacity of small cells for very high speed data rates. And for that we need, in my perspective, we need to use every single infrastructure that is available, either physical, wireless. Let's use everything and try to have a holistic approach to that, to find ways to orchestrate all those assets that are available, and not trying to bet only in one technology that will solve everything.
Okay, thank you, Thiago. We just have a question coming in from Bernard Lemoine. Could you please elaborate on neutral host network? Who of you would like to jump on this?
Yeah, I can take this maybe,
Heidi,
because it was in my slide. I'm actually cooperating or involved in a research project in Finland that is working on the neutral host. And the view of this research project is that it's actually a smart city project. So the city or some other actor on behalf, maybe cooperating with the city, can provide also connectivity, but also the infrastructure for building the network, and be kind of a neutral host to provide sites, or even to provide connectivity to other operators and in cooperation. For example, they could build in the 26 gigahertz band, there could be a private network for the smart city applications from the city perspective. And then when building this small cell network, they could also then provide the same sites, or even to provide spectrum sharing in the same, in the same base stations. In the future, this might be possible for the national MNOs to take part in that same network. So that's kind of the idea of a neutral host. There could be many different kind of operative and cooperative models, and it's still developing, but that's the idea behind it. It's kind of a private-public partnership also, or could be if the neutral host is a public actor, like the city.
Okay, thank you very much, Heidi. Alexander, more a question for you. Looking a little bit more in the future, we are, as we have heard, something like 8-9 years away from the deployment of 6G, but still, it's already the right moment to speak about it. Where do you see, in combination with 6G, the possibilities for private networks now especially?
Yeah, when I first heard about 5G, it was back in 2013. So it's a similar timeline we have right now, and now we are speaking about 6G. So you see that we are in some kind of good cycle moving forward. For private networks, I see a lot of possibilities in 6G. Either we heard that the 6G environment will be on a much smaller cell, so you will have to build up on other networks and how they combine to each other. On the other side, you have to think about how we can bring data then to those networks as well. So you have to think about a different complete network structure, not only one operator which is just delivering with its own spectrum on it. And private networks will build a key element in this environment of 6G. Either if they are thought about some kind of body networks, we speak about already today with Wi-Fi equipment and maybe 5G for a very low power equipment which may be available, but also on the private scale in our homes. If you think about smart health or smart home, we have started the trend towards a more connected home at all, and that will be, you would like to keep your security in your own home to a certain degree, and therefore you would like to have control on your own network to a certain degree, if you wish to, and that needs to be implemented then for ubiquitous connectivity further on. So therefore I see definitely a trend towards more private networks, but then we need to be clear regarding spectrum sharing and the connectivity between those networks, because nobody can understand then if you leave your home, your mobile turns off. That may be the wrong signal to the public, so therefore we need to really build on a good combination of all these networks in the future and then moving forward. And last point on 6G is also that that 6G is thinking about sensing networks in particular they are in the sub-terahertz frequencies, and those sensing environment needs to be carefully examined as well in order not to provide any interference.
Okay, thank you very much, Alexander. Another question which came in also from Bernard Lemoine, which is probably more for Heidi. Do you think that tower companies could use this NHN concept?
Yes, definitely. Why not?
Okay, that was a short and clear answer.
Yeah, yeah. It's an opportunity for many different actors, and yeah, they are, of course, they are one of them. And they could also, if they want to access, I mean, we have the local spectrum available, maybe more wide area private networks available, then they could build this kind of private networks and also provide for the commercial MNOs to provide, or to put their equipment and provide their connectivity from them. So yes, that's a cooperation. But this will require new kind of operational and business models, and we are not there yet, but they are being investigated, I think, all the time.
Great, thank you very much, Heidi. Maybe just to wrap up the session, one last question to you, Heidi. Looking into the future, how to work with research and innovation to discover the trends? Because you need always to be kind of ahead of the trends and to define what kind of trends are coming to regulate them in the right way. How do you do that? How do you work with the research and innovation to figure out what trends are coming up?
Yes, it's all about an active dialogue with companies, research organizations, and the public sector. When we find a research project that is very deep into the spectrum and regulation, then we actually join that project to have the very active dialogue even on the details. And to understand where we are going. But then also it's very important, the dialogue is important also for the innovation and research community to understand the regulatory perspective and what is possible and what is not. So it's really an active dialogue. But we also do other things. We arrange webinars and we have newsletters and then hackathons on cybersecurity for 5G. So there are many different kinds of cooperation. And of course, having the international cooperation in spectrum. We also participate, for example, in the European Space Agency's 6G program work. So it's just to be involved in many places and have an active dialogue. Yeah.
Perfect. Thank you very much, Heidi. Heidi Himmanen, Alexander Kühn, Thiago Rodriguez. Thank you very much to all three of you. And it was, I cannot just say it was super interesting. Thank you very much for it. Now let's move over right away. After an applause, please. Not to forget this. Let's move over to our next panel discussion. And we're going to speak here about the hen or the egg. That's kind of a very cryptical title. And for this, I invite on stage with me, on one hand, Kimmo Pentikainen, Vice President, Business Development Production from Elisa Corporation from Finland. She's virtually connected. And on stage live with me, Dr. Chiang Tang, Senior Researcher from the Luxembourg Institute of Science and Technology. Welcome to both of you, and glad to have you with me here. And, well, the first thing, we can start right away with an introduction of Kimmo. Go ahead, and then we're going to move over to you, Chiang. Kimmo, welcome.
Thank you, and it's a pleasure to be here now virtually online from Finland. So, as already introduced, I'm working in Elisa Corporation. It's a market leader in Finland on communication services. And I think it's an exciting market what we have here. It's an exciting market in terms that actually here our customers are using more mobile data on average than anywhere else in the world. We've been on 5G already for years, one of the first launching commercial 5G network, and also launching dozens of exciting 5G services. Looking forward to the debate and elaborating more what 5G is going to bring and create sustainable future for everyone.
Great, thank you very much, Kimmo. I think we have also a video that you provided us.
Hello everyone, my name is Kimmo Pentikäinen and I'm working in Elisa Corporation. We've been in business pretty long time. We've been in business in 140 years. It has been good business, but in the last 6 years, it has been best ever. In the last 6 years, we have been making best ever results year after year. And the reason is that we've been finding the right business model on 4G services. Actually, at the moment, our customers in Finland are using more data than anywhere else in the world. So it's 11 times more data per average user than in Germany, 6 times more than in UK, and 4 times more than the United States. It's the highest user of mobile data than any other country in the world. And I would say that's a perfect position to innovate 5G services. And that's important for us because always the new generation of communication standardization is changing the game. That was true with the 3G, that was true with the 4G, and again with the 5G. It's coming always with something you never predicted. One thing is for sure, it's something else you expected it will be. And it will be changing our life in a fundamental way. The way we are living, the way we are having the future of society. That's the reason we've been having these 5G services. New 5G services over the last 2 years, we've been launching 28 new services, many of them first in the world, together with the customers. Let's have a few examples. One is 4K live streaming. What we are nowadays bringing for everyone, free of charge. You just have a 5G phone and a 5G subscription, and you can start to stream any of your favorite moments, whether it's your kids' football match, to your dearest family, parents, anybody, to see clear and crisp on the big 4K screen. That's available for everyone. And we demonstrated how well it worked. On February, half a year ago, we were streaming for millions audience, Junior World Skip Championship from the northern Finland. With 13 5G phones, and it all worked perfectly. That's demonstrating the promises of 5G in the future. We've been bringing 8K resolution for schools, for having live streaming, and what I'm really excited, we've been supporting University Hospital in Helsinki for developing together a remote control robot for supporting the work of the nurses on COVID-19 ward. And it has been saving time, it has been saving costs and helping on these critical moments. Drones, they are changing our life, and 5G is bringing outstanding video quality, even 8K video quality, what we've been able to provide as a service. And all you can do remotely. You can have remote access, and you can have different kind of services on the back office by using drones 100 kilometers away for having different kind of image recognition, for delivering parcels, you name it. Autonomous driving cars, they might be reality in one day, but before that already remote control of heavy machines, it's already reality. And that's what we did first in the world, remote control of tractor, with the local tractor manufacturer, demonstrated that it's already reality. And now we've been working for providing communication on the field. So perhaps you at least me, I'm using daily Teams, Zoom on our office work. But when you are working on field, on farming, for instance, you can't use Zoom. But still you have a need to communicate, for instance, on the back office. What's wrong now on my combine? And for that reason, we've been developing this multiple camera system. And it works either it's on farming, either it's on constructions, or public safety. Now this is going to be a game changer. That's going to change how we are actually living and working through 5G.
Thank you very much, Kimmo. I think that was already quite a good overview what is possible with 5G, and especially also examples that everybody of us can probably identify themselves, not necessarily driving with a tractor, but many other things also. Over to you, Jiang Tang. Can stay. Can you just give a little introduction about what you're doing, also what your activities are, before we are going to dive into the discussion where we're going to discover even more possibilities what 5G can do?
Okay, so good morning, everybody. So I'm, as Peter has said, so I'm a senior scientist from LIST. So my background is cybersecurity and privacy protection, but recently I'm diving into the new technologies like machine learning, like artificial intelligence, like 5G, and to study the future use cases and to say what are the challenges we are facing towards cybersecurity and those new use cases. Yeah.
Okay, thank you very much. Let's start maybe also from your side. We have seen already now from Kimmo's side a lot of applications. Where do you see, for example, kind of killer applications for 5G? Applications which might not be necessarily so obvious and so visible also to the public. Live streaming is something which is very visible, but there are also a lot of applications behind the scenes, behind the curtains.
So basically today, also in this conference, we have heard a lot of applications for 5G and for artificial intelligence. But most of those applications are centralized, which means that there would be a company which is offering the service so that the company could collect data and do artificial intelligence or do machine learning and provide service to the customers. But from my opinion, in the future, we would have a more decentralized world. So we would try to do business in a more peer-to-peer style. So I guess you have heard the term blockchain or DLT. So those technologies have been initially aimed for financial services, but now we are trying to use those technologies to other applications as well. So I would say that now we are moving from a more centralized world to a more decentralized world for a lot of reasons, of course.
Well, if I may contribute from my side also, one of the applications that I see for the future is just something very practical, something that we have here around. We are surrounded here by different cameras, like almost an armada of different cameras. And I see that we have 3 so-called PTZ cameras. That means remote-controlled cameras. We have also the sound engineers over there, the video engineers which are over here. All these are fields which in the future, and not so far future, by the way, can be done remotely. The PTZ cameras can be installed and controlled from the other side of the world without any problems. The video mix can be done from somewhere else, remotely. 5G makes it possible. Same as also for the sound mix. Peter, you're going to be, next time you're going to probably work maybe from home. You're going to have your studio, you're going to do the mix there. So it's going to be very different, but a little bit more lonely at the same time also. Kimmo, a question to you, maybe from the social aspect. Where do you see also new technologies which can help 5G technologies to enforce social relationships, for example, bringing people together, maybe specifically on this area?
Thank you, Peter. I think that's a really important question. And I would say that it is important to understand that COVID-19 has been a huge experimentation in our society globally. And it's going to change in a permanent way how we are going to work. We've been already seeing that on different kind of office work. People been finding out that it's pretty awesome to work at home. That's actually what I'm doing now. Through 5G, I'm on my home office, and I'm actually now having lunch together with my wife and my kids, and it's a different kind of context that there used to be working at the office. Of course, it's hybrid work in the future, so it's a combination of being on the office and being at the home. And this kind of same opportunity is now available in a variety of different professions. So that's one of the big impacts of 5G. That makes possible that, as we have been seeing in that video, that the farmer can actually have a support from the back office. So the back office can be there on the field and see everything the farmer is saying. It makes possible that you can remotely drive the drone over 1,000 kilometers away. We've been already demonstrating. It makes it possible that nurses can actually support and help without being there with the video robot. So 5G, as we already illustrated, through making possible multiple cameras, make possible high resolution, make it possible to be actually present somewhere be at the moment. Remote presence is one of the dimensions. Another dimension is remote control of devices, and that's going to increase greatly. That will be increasing flexibility. It will be also supporting how we are living together as a society. So it is a new kind of organized days.
Okay, thank you very much, Kimmo. Question over to you, Chang. One question which is maybe more kind of a technical question: how to keep the digital sovereignty in the future applications based on new technologies such as IoT or 5G?
Okay, actually this is a very challenging problem nowadays. I think very recently Europe finally realized this problem because we are now talking a lot about digital sovereignty. So if we think about the services nowadays we are using, for example, we are using Google, we are using Amazon, we are using Facebook. Our data is shipped to the US, for example. So that, of course, I mean, US is a friend to Europe, so everything is friendly, so there's no harm. But I would say that sovereignty happens at two levels. So in the first level is the individuals. So now, if we use the applications, any smart applications, we use smart gadgets, smartphone, et cetera, so we contribute our data to the third-party service provider, like Google, like any other service provider. So basically, as a consumer, we are somehow exchange the service based on our data. But in the future, I think we would like to that we should control the data, and we should be able to determine what the data would be used for. And not only for the personal usage, but also for the general social good. Of course, at the national level, there's also a big concern here because data could be used maliciously. So if you look at the US election in the past 2 terms, you might have heard the story of Cambridge Analytica. You know that information nowadays is so powerful that could be used to influence election, to influence every perspective of your life. So I would say that it's important, but it's also very challenging. And this is another reason that we should slightly move away from the centralized business models to the more decentralized ones, so that for the users or for the local players to take control of the data.
I see we have a lot of challenges ahead of us when it comes to that, but also it needs to be creating the awareness with the people that they know what happens to their data, which is already now very often not the case. I know that Google knows partly much more about myself than I know about myself. Respectively, you see very well when you Google for a shop, then you see the opening hours and you see these nice graphics where you see how many people typically come to certain hours. Most of the people that I speak outside with, they don't know where these data come from, and they are not aware that by default on their phone, they have the geolocalization on Google Maps activated, and that Google knows very well when they are going into this shop. Everybody is contributing to that without even knowing it. But moving over to another topic also, which is very interesting, artificial intelligence, because the combination between 5G and artificial intelligence seems to me something very interesting. More question to Kimmo also, how 5G can help the growth of artificial intelligence, and how then can AI, if we see it, help the deployment and maintenance of 5G? There we come back actually to the chicken and the egg at the end of the day.
I think that's again a great question, because now when we speak about AI, in practice we are speaking about machine learning, and it means that you should have lots of data to train different machine learning models. Now, as I already demonstrated, 5G is going to be a big impact for actually accelerating the amount of video data and live video data there. Also, from the network architecture perspective, it will be possible that while it's a live data, it's also something that it's there on the edge of the network, where it can be also combined with the machine learning. All this makes possible that we will have a vast amount of more data for image recognition. And what can be actually utilized now? And I was giving this demonstration about having multiple cameras on the combine and supporting the driver, the farmer, to do the harvesting with the help and support of the back office for any kind of technical problems or advices how to do the harvesting. Beside that, when we have actually high quality video data from multiple cameras, that's an outstanding opportunity to utilize machine learning to have an add-on automatic guidance based on the previous data gathered and then giving the automatic guidance, for instance, in this case, for the farmer, how to do an optimized farming on those previous weeks. Then the harvesting will be done. So, to summarize your question, surely 5G is going to be perhaps the biggest driver of machine learning that we have ever seen.
Perfect. Thank you very much, Kimmo. Jiang, we have also a presentation from your side, a PowerPoint. Could we start this one now so they can just make it a little bit more decentralized also?
Okay, so basically we have covered some aspects of my talk. So, so here I'm going to mention 3 use cases which are designed for the future. So they might not exist today, but they are coming. I'm pretty sure about that. So the first one is about democratization of IoT data. So today we have heard a lot of stories like IoT could be used in smart cities, in smart manufacturing, etc., etc. But as we have just said, today still data are controlled by, let's say, a handful of big companies or organizations. But on the other hand, from the innovation perspective, when I talk to small and medium companies which try to do innovation in artificial intelligence or machine learning, they just complain that, okay, we don't have data. We don't have enough data to help us to build the machine learning models to build a reliable artificial intelligence system. So this is why several years ago, the IBM was proposing that, okay, we should have a democratized scenario for IoT data, which basically 5G would really contribute to connect the IoT devices together. And then we could use technologies like blockchain or DLT to securely manage the data. And by doing so,
that the data could become more like a commodity, so that data could be traded and transacted and recorded on the blockchain. So this is not happening in Europe, but I can see some signs this is happening in Asia, for example. So as the second example, today we have been excited by 5G because 5G is giving us high throughput, low latency, and machine-to-machine communication, et cetera, et cetera. And network slicing is a key technology that we use for different verticals. For example, we could have one slice for vehicular communication, another slice for remote surgery or remote e-health, okay? But still, today, we need to preset the capacity of the slice. So in the future, we could imagine that we would have a more real-time, dynamic, and configurable setting. So that here is a use case which, again, is proposed by researchers from Finland. So Finland is really a star in this conference. So basically, we can say that for vehicular communication, we can do machine learning to let's say, to reduce the delay for the communication. On the other hand, the machine learning results could be used by the network service provider to optimize the configuration for the slice, so that it's a win-win situation in this case. So the last one is we are entering in the surveillance economy. So basically, we have sensors, we have the hyper-connectivity, benefiting from 5G, from the next generation of Wi-Fi, et cetera, et cetera. So that people are really imagining and developing the next generation of smart city. So here, in the US, there's a lab called Sidewalk Labs, which is a subsidy from Alphabet. So Google is another company of this big organization. So Sidewalk Labs in 2017 collaborated with Toronto to build a smart community in the waterfront district. So in this next generation smart city, basically sensors would be put in every place in the public space and also in the private space. And the robots would be walking on the street to facilitate, for example, the delivery of goods from the shops to the households, et cetera, et cetera. And the body networks could detect the emotions of the humans in the community, and if there's, let's say, high pressure or there's some kind of depression, so entertainment would be recommended to those users to help them come out from the depression. So it's really smart next generation society. Okay, so I would say that the future is quite interesting, and we have a lot of exciting new use cases and new inventions, both from the technology perspective and from the application perspective. But on the other hand, we are facing big challenges. So among all, privacy is a challenge. So already in 2016-17, the Consumer Council of Norway has done a study with the smart toys in the shops. They have figured out that the children are consistently spied by the manufacturers of those toys. And there's huge privacy concerns there. Of course, we don't notice it because we know that privacy could happen in a very salient manner. Of course, in the next generation, when everything is connected, the privacy issues would be really exaggerated. So to this end, actually, last week, Amazon has introduced a new smart, hyperly connected equipment, which is a robot which would stay at your home and walk around at your home and sense everything from your home, and to do machine learning locally and to communicate and to allow you to communicate with your friends, with your peers. So that I can imagine that in the next round, the robots at different households would make friends with each other and communicate with each other. So it's exciting, but again, there are serious privacy issues. So regarding machine learning, or artificial intelligence, we have heard a lot about this. It's very useful, it's great, but we are also very concerned with the trustworthiness of this technology, or this range of technologies. So there are ethical issues, there are bias, there are discrimination issues, etc., etc. So I think the European Commission has initiated a lot of initiatives to focus on those issues. And unless we could address those issues, we have some concerns when we, let's say, use the new services enabled by 5G, by IoT, etc., etc. So,
thank you very much, John. Well, this brings us also to the end of the panel discussion. For me, one of the key takeaways that I have taken really is that 5G by itself is not nothing, but worth only a little bit. It's the combination with the different technologies which allows so many exciting applications that we have seen thanks to Kimmo Pentikainen and Dr. Tang from the University of Luxembourg and Kimmo from Finland. Thank you to both of you, and a very warm applause from everybody to you both also for being here virtually and in presence. Thank you very much. Now, before I'm going to let you go into your well-deserved coffee break, maybe those who are connected virtually, you might get a cup of coffee. The other ones, they can mingle here around, go to the networking areas, have a look at the virtual stands and physical stands that we have of the exhibitors. But also, especially, I would like to highlight the workshops that we have in the afternoon. Just to go quickly through the workshops that we will have at 2 o'clock, we're kicking off the workshop 5G and Microwaves by the Luxembourg Science Center. I know pretty well the Luxembourg Science Center. I know that they are doing great things. Definitely something not to miss. Unfortunately, only physical attendance, but we have also at the same time, we have the workshop 5G for satellite and terrestrial services. How is virtualization transforming the ability to respond to rapidly changing user demands by SES? That's physical and online, so just feel free to register for it and to be there. At the same time, again at 2 o'clock, the workshop Augmented Reality and 5G, a perfect match for future B2B use cases by Telindus. It's also virtually and physically, you can still register for it. And then we have indoor PPDR coverage by SMC, Service Renita, also online and physical. And then we come to 3:35, the workshop Empowering Rural Communities and Digitalizing Agriculture with 5C from SATCOM, Internet of Things, and Cloud Technologies by LIST. Both here again, virtual and in person. Or you can choose the SNS Sensor Nexus Symphony, public investment in 5G plus 6G with a new funding landscape by Lux Innovation. Also online and in person. Or you have the choice today, unmanned aerial vehicles and 5G by SNT. Again, here also virtual and in person. Enjoy your time, and we are going to be here very soon again for the follow-up of the conference. Thank you very much.